All right, I wanted to take a little bit of time just to go over this last handout that I gave you. That was, I forget what it was called, something like approximating Riemann sums, left, right, middle, trapezoid, something like that. So anyway, it'll look familiar to you. You know what I'm talking about here. So what we will be getting into is this notation here. This is the integral notation, definite integrals. There's also indefinite integrals. We'll get into all of that stuff. You've seen this on a couple of worksheets. We haven't really talked about it at all yet. We've just been kind of doing the math behind it. So if you look at these points up here, each one of these points is where they kind of separated the graph to do the rectangles. So this one says we're going from -2 to 3, so we're going from -2 up to 3 using two rectangles. So it's using this endpoint and this endpoint here. So if we look at this, or I'm sorry, and this endpoint here for 3. So if you look at this first one, the height was 5 and the width was 2. So if the height is 5, that's right here, and the width of 2 means we had this rectangle right here. And the other one had a height of 2 and a width of 3, which means we had this rectangle here. So hopefully you can see there that that is a right Riemann sum. I'm going to abbreviate that, right Riemann sum. The next one says we're going from 0 to 9. Let me erase this stuff here. We're going from 0 to 9. And this says with 4 subintervals. So we're going from 0 here. So we're going to use, so we should have 5 dots basically. So here's 4 and 5. So the first one says 5 with a width of 3. So we know the width was 3, and then the height being 5 means we're going all the way up here. So you can see there that that's a left endpoint. The next one, 2 and 1, means a width of 1, height of 2. Again, left endpoint. Next one has a height of 3 and a width of 2. Right, height of 3, width of 2. So that's a left endpoint, and then the height of 6 and a width of 3 gets us all the way out there to 9. So all of those are left Riemann sums. Okay, so let's move on to the next page, which had this table right here. Now this table is only relate. Now this is kind of like, I don't understand why they put these. They kind of lumped them together here. Because v of t is your velocity, and then you have the absolute value of the velocity there. F of x, I don't know what f of x is. It's just some other function going from 0 to 6. And if you look here, they don't really give you any values for f. They're just saying f of 0, f of 2, f of 4, and then they split it up into equal intervals. So going from 0 to 6, 3 intervals, if you remember that formula, would be 6 minus 0 divided by 3. So that means that the height is 2. And you know, that's where all of these 2's come from. So, but because it started with 0 and then did 2 and then 4, instead of starting at 2 and then 4 and then 6, that means this started at the left-hand side. So these are left Riemann sum. Now I skipped over that first one, so I'm going to come back up here. Going from 0 to 6 in this section here, in 2 intervals, so there's 1 and there's 2. This said 10 times 3, so here's 10 times the width of 3. And then the next one was -15, but because of the absolute value, we made it a +15 times the width of 3. So this one is also a left Riemann sum. Hopefully that makes sense to you, what I was explaining there. All right, so now let's fill in the blank here. There's a little check for understanding here. So for any subinterval, a blank involves adding areas of rectangles where the height of y value is on the left side. That's a dead giveaway right there. If it's on the left side, that means it is a left Riemann sum. A blank involves adding the areas of rectangles with a height on the right side, means that this one would then be a right Riemann sum. Okay, pretty straightforward there. So, all right, on to the next table here. So we want to first of all identify which of these columns is bigger or greater, and then kind of give a little explanation as to why. So in this first one here, column A is greater, and that's because a right Riemann sum, the first one here, this right Riemann sum, is an overestimate, and the trapezoid sum would be an underestimate. Okay, so a right Riemann sum, like if you look at here, if we had some triangles, or I'm sorry, rectangles like this, you can see those are all going to be overestimates. And if I were to draw some trapezoids in here, if I pick these 2 points like this and say, well, here's my parts and connect them, that would be an underestimate. I kind of tried to make it a little more dramatic just to show that it is an underestimate. So let's look at these at the next one here. Which of these columns is greater? So if I look at a right Riemann sum, that would be something like this. Okay, and we can see that a right Riemann sum here, regardless of how many rectangles we do, it would be an underestimate. This is exact. That is the notation for the exact area. That is not an under or an overestimate. That is exact. So since column A was under and column B was over, that means that column B would be greater. Okay, and you can say something like that. Column B is greater because a right Riemann sum would be an underestimate, and this integral notation right here is the exact area. All right, let's keep going with this table here. First of all, if you want to, you can draw all of the rectangles, trapezoids, whatever in there, but I'm basically just going to be talking about what they would be. You can draw them in as you go if you want. So if we have, first of all, we have to identify whether this is an over or an underestimate. Because if it's an underestimate, then B is correct. If it's an overestimate, then A is correct because it would have more, because there's fewer subintervals. It's going to have more of whatever it is, an over or an under. I guess it would be A either, well, it would be more of an underestimate, meaning that B would be greater. So we need to identify what's going on here. So if I draw a trapezoid somewhere in here, what do we have? You can see here that we have an overestimate. So that means that column A would be greater, and the reason why it's greater here is because if you have more subintervals, you end up getting closer to the exact area. So if you're closer to the exact area, that's less of an overestimate. It's still an overestimate, but it's less of an overestimate. So you could say something like that on that one. The next one here, a trapezoid sum or a left Riemann sum. Let's look at what a left Riemann sum would look like here. Well, here's a left Riemann sum. If I do all of these from the left-hand side, you can see that's an overestimate, right? So that's an overestimate. And you can write those little notes in there, like this is an over. But then look at a trapezoid. Well, if I have a trapezoid in here, guess what? It's still an overestimate. So this one is still an overestimate, but it's less of an overestimate. So B is greater. And what I would say there is, even though the trapezoid sum and a left Riemann sum are both overestimates, the trapezoid sum is less of an overestimate. So B would have a greater area. And the last one here, the right Riemann sum with 3 equal intervals, subintervals, or 6 subintervals. Again, we want to see if it's an over or an under. And if I do a right interval here, you can see that it's an overestimate. So if I do an overestimate, then A would be greater, even though they are both overestimates. If you have fewer subintervals, your area will always be greater than if you're doing the same Riemann sum, left, right, whatever, but with more subintervals. So something like that is what your explanation should sound like. Okay, so let's move on here to this next check for understanding here. I tried to fit it all on one page. So hopefully you can see all this. So what I did was I looked at 1, 2, 3, and 4, and I wanted to decide which of these, A, B, C, or D, which one goes with it. So a trapezoidal approximation that overestimates. An overestimate is going to be either C or D, because those, if you draw a trapezoid in here, it's going to have an overestimate. Okay, here or here. C or D. Those are both overestimates for a trapezoid. So then what we have to look at is, let's first of all, let's look at the next part here. The left Riemann sum underestimates. So if I do a left Riemann sum for this one, you can see that this is an underestimate, right? There's some gray area left in there. So that's C, which means that this one has to be D, but let's verify. The right Riemann sum overestimates. So if I do a right Riemann sum, did I get that right? I'm sorry, left. That's left overestimates. I'm sorry, not right. Left overestimates. I'm going to say a right one would not overestimate. A right one would still be under. But if we do a left Riemann sum here and actually read the question correctly, you can see here that that is an overestimate. So now we need to look at our other two and decide what is happening here. Now, a left Riemann, both of the trapezoids say under. Trapezoid under, trapezoid under. So we need to look at a left Riemann being an overestimate. So if I do a left Riemann sum in here, you can see that that's an underestimate, right? So that means this one has to be A, which means this one is B. Okay, so if I do a left Riemann sum in here, it's going to be an overestimate. So that's your final answer there, C, B, D, A. And now we're going on to this second part, which is basically just like the first part. It's just you're doing a little bit more of the work. Instead of them writing out the work and asking you is it left or right, they're telling you 3 rectangles and left. So we're going from 3 to 9. So 3 to 9. Using 3 subintervals. So again, we're using these dots as our widths. Okay, now a left Riemann sum is going to start here and go like this. The next one will go from here over to here. There's 2 rectangles. And then the last one will look like this, only a lot nicer because I can't draw a straight line on this tablet. But there's your 3 rectangles. So what does that look like? Well, the width of the first part is, let's do height is 2 times width is 1, plus the height is 3 on the next one. This one right here, the height is 3, width is 2. Plus the last one has a height of 6 and a width going 1, 2, 3. So that would be your approximation. And you could do that. 2 plus 6 plus 18 gives you 26. Okay. The next one here, let me erase all this stuff here. The next one is going from 0 to 9, now with 4 subintervals. So from 0 to 9, 4 subintervals. Now we're doing right Riemann sum. So we're going from here to here. Form a rectangle from the right hand side, looks like this. Next one, here to here from the right hand side, looks like this. Next one, from here over to here, again from the right hand side, will look like that. And the last one, from here straight over and straight down, will form that. So let's write what is the area here. So height is 2. Width is 3 for the first rectangle. Second rectangle, plus height is 3, width is 1. Ignore those parentheses, they're kind of messy. Next one, the height is 6, width is 2. And the last one, the height is 4, and the width is 3. And again, just like the last one, you can do all that math. 2 times 3 is 6, plus 3, plus 12, plus 12. So we get 33. 24 and 6 is 30, plus 3 is 33. The next one, again, the v of t is relating to the table. F of x is just f of x, okay? So a right Riemann sum over 3 intervals means that the width of each of these will be 8. So we're going to have the height from the right-hand side will be f of 8 times the height, which is 8. The next one, I don't know why I'm doing these out of order. I just felt like it. The next one, the right-hand side would be 16 times the height, which is 8. Plus the last one, f of the right-hand side would be 24 times the height of 8. Excuse me. Now for this one, we're going from 0 to 16 with 4 subintervals. So there's 1, 2, 3, 4. Okay, so we're going to do width times height. So the width of the first one is 4. Left Riemann sum means we're using this value, so times 12. Put that in parentheses. Plus the width of the next one is again 4 times left-hand side is 20. The next one, the width again is 4 times the left-hand side is negative 8, but because it's absolute value, we're going to use a positive 8. And the last one, the width is again 4. Oh, sorry, I didn't underline that one. Left-hand interval would be negative 12. Absolute value is positive 12. And again, you could plug this in your calculator and get your answer. This one here, you don't have that option because you don't know what f is. If I tell you f is x squared or ln of x or something like that, you could do it. But in this case, you can't do that. So we don't really have that option. We have to leave it like that. Where this one up here, you could actually, get your answers there. All right, last part here. This is something I would have had you do in class, is just kind of discuss this and just have a conversation about it, but we don't really have that option. So I will tell you what I see are the biggest mistakes that people tend to have. The number one mistake, I'm going to come back here. The number one mistake I think I see is like from a table, instead of finding the difference in these and saying that the width is 4, people will say, well, they look at the left-hand column and they just multiply these numbers. And they say, well, left-hand column, I'm going to multiply these. Left-hand column, I multiply these. So you have to remember it's the width times the height of the left-hand column. So just keep that in mind, because that's probably the biggest mistake that I see, is people just go to the left-hand side of the table and multiply the numbers. Other than that, I can't really think of too many other issues that show up a lot. Sometimes people separate the tables incorrectly, and if it says 4, they just do like the first 4 instead of, sometimes if you have a table with like 12 columns and they say 4 subintervals, sometimes people will just take the first 4 instead of splitting it up and saying each column has to have 3, or each rectangle would have 3 columns, if you understand what I'm saying. So that it shows up sometimes, but that's not really all that common. There's other little errors that show up here and there, but none of them are as common as that other one. So if you have other things, put it in the comment. If you thought of other mistakes, maybe you were making some mistakes, and just write that in the comment section. That way it will help other people to catch their mistakes before submitting any tests or anything like that. So if you have any questions, just let me know. But I did want to take some time to go over this and just review some things while we were coming back from break. So if you have questions, let me know.